morning, I am Srilekha, Department of Chemistry. Today I am going to take about on the topics of estimation of alkalinity in water sample by EDTA. So here I am going to confirm that the definitions of the EDTA is to explain the EDTA of the solution. So here the water samples can be calculated by using this alkalinity, carbonates and the bicarbonates to form the pH of the solution. So here the alkalinity of the solution is going to identify the water sample in the hydroxide group OH group and the chloride group Cl minus group and the bicarbonate is CO3 groups in this. So here we are using this short procedure to form the reactions. So here the burette solution. What is the burette solution? We have been using the what the titrating on experiment we are doing? Titrating on the solution. HCl solution. So we are adding the burette solution as HCl solution for both the titration 1 and the titration 2. And what is the burette solution? Water sample. So we are making a water sample with different concentration based on this alkalinity, carbonate, chlorides and the bicarbonates. Okay. So what is the indicator we are adding to indicate the end point of the reactions? Phenolphthalein and methyl orange. So phenolphthalein which indicates a pink color, and by titrating it with the burette solution in HCl, it turns as a disappearance of blue, pink color. Okay. So what is the second titration of indicator? Methyl orange. So when we are adding this methyl orange, it shows a yellowish color, and while pipetting by this using this instrument, it changes to a reddish yellow orange. It indicates the end point of the reaction, whether it is an alkalinity or hydroxide or carbonates for the solutions. So what is the temperature we are maintaining to this experiment? Room temperature. At this 30 degrees Celsius, we are maintaining through the titration 1 and the titration 2 for this experiment. And what is the values we are using additional solution? No, we are not using this additional solution. We are adding only this additional as a reagent only, the phenolphthalein and the methyl orange. Okay. So now I am adding this burette solution with HCl in the burette. We have to mix with this burette solution, and we have to take this burette solution of HCl in the burette and add in the funnel. So we can add the solution till 0, always we can add the excess solution and we can adjust the solution to 0 readings. So after fitting with 0 readings, and we have to fit with this burette solution. Okay, and next we have to add the normal water sample in the 20 ml of water sample in the conical flask. Okay. So while adding the 20 ml of the water sample, and next we have adding the additional reagent of titration 1 with the phenolphthalein solution. So now the solution turns as a pink color solution. Now I am going to titrate with this burette solution, and the solution from the end point disappears from the pink solution. So with this, so while titrating it with drop by drops, we have to set this burette solution. So while drop by drop titrating with this value, we have this strong concentration for the HCl solution. So it gives the value of the 1 ml of the solution. So by using this, the concentration of HCl changes, whether it is in the 0.2 or 0.3, it can vary the changes from the 10 or 11, 12, it's approximately. Okay. So from this same equation, we have to add the second titration of the additional reagent as a methyl orange. So with this solution, the solution turns as a yellowish color. While again titrating with this same burette solution, we have to make the reddish orange. Okay, the solution turns as a reddish orange with this yellowish to reddish orange. So this is the end point of the reaction, whether the hydroxide or alkalinity carbonates can be present in this water sample by using this phenolphthalein and the methyl orange. Okay, so with this readings, by two readings, we have the formula for substituting this equation, that is the pH equal to, so this is the formula for titration, P equal to 0. First formula equal to P is 0, phenolphthalein. Whether the P equal to 0, the OH hydroxide group, it will comes for the 0 value. Whether it is in the P is equal to M, the solution of the readings, whether the P is equal to M, the readings will be a M is equal to 1. The M is will be a greater value. Okay. And the next formula is P is equal to half M. Whether it is a P stable and it reaches to a half M value, it can react as a 0 for that hydroxide group only. So this is the formula calculation, whether for substituting this equation for one value and the two value titrations. So by using this formula, we can substitute for the values by V1 N1 equal to V2. Okay, so here we have know the N of the solution. For substituting the V1, 1 into 0 point, that is concentration, 0.2. Okay, so we are adding. So from this experiment, what you have learned about this water samples? So disappearance of the phenolphthalein solution. And you? Also, that's from the first titration to the second titration, it changes the color value. So this is the same value, same solution, but the color variation is a different formation. So with this equation, okay. So this is the experiment to determine the alkalinity of the water samples. Thank you.